In this video, we'll be looking at subtraction in second grade. The TEKS are 2.4b, 2.4c, 2.4d, and 2.7c. Our examples in this video are all going to be two-digit subtraction, but after you've done your addition and subtraction, you will move on into three-digit, and this video will work for the instruction as well. So we're going to start out with word problems that require regrouping and problems that require regrouping and ones that don't require regrouping. There's no reason for us to keep anything back from the students. It happens in the real world, and we need to just kind of put it out there for them to begin with. When we're working with subtraction, we want to start out by working with manipulatives with the students and letting them kind of find their own strategies or ideas that they have for subtracting. And one manipulative that we tend to use in second grade are base 10 blocks. They work out perfect. The students know how to use them. They have practice with them from place value. But another thing you can use are the unifix cubes or linking cubes. They will do the exact same thing. They actually offer the benefit of not having to worry about trading and taking a set of 10 and trading out for anything. I can just take these, break them apart, and take my 10 ones and put them in the ones column or with the rest of the ones there without having to do any type of trading. So either manipulative would work. If I was starting with subtraction with second graders and using these larger numbers, I would probably start out a day just letting them explore, talking about what happens when we're doing subtracting with the linking cubes first, and then transition into the base 10 blocks, and then let that be a choice that the students can make. The base 10 blocks are easier to draw pictorially, but these allow the breaking up a little bit easier. So we're going to set those off to the side, move these out of the way, and we're going to look at what we can kind of provide the students and show them how, or allow them actually to show us their flexible strategies. So we're going to start out with the problem 52 minus 19. And we're going to just give the students the manipulative and let them figure out, let them show some strategies. What are they bringing to the table to tell us where to lead our discussion? So if we have 52, we're taking away 19, students might just very easily count out 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I can break these apart, take all this away, and now I have what's left when I take 52 minus 19, and I get 33. So that's one way that the students could show us their flexible strategy of subtraction. When we start talking about students and different strategies and us being flexible, we're not going to require the students any one particular strategy. We're just going to expose them to the strategies and let them find the one or move into the one that works best for them. So one algorithm, which is just a step-by-step method that we can do with subtraction, is showing the students a partial difference. And it works the same way, and if I have the manipulative, I can kind of see what's happening here and work the manipulative at the same time. When we would work with partial differences, this is basically just taking our numbers, putting them into expanded form, 50 plus 2 and 10 plus 9, and then subtracting these two parts. And I'm going to work through it concretely as well as model what's happening abstractly for the students. So here I would take away the 10, so I would remove the 10 that I have here, and I'm going to show that happening abstractly as well. Now I'm going to move to my ones, and I need to take away the ones that I have, but I have 2 and I need to take away 9. So this is where we're going to model for the students that I'm going to take this and I'm going to break it apart. So I have 40, and now I'm going to take away another 10, and I'm going to break this apart into my ones. And now I don't have 10 anymore, and I don't have just 2, or I don't have just 10. I have 2 and 10, so that's going to give me the 12. And then I can take away the 9. And I can see now that I have 3 left. And then I'm going to take this expanded form, put it together, and I should see that I have 33 left over. So this is working through partial differences using expanded form to help us do the subtraction. It works really, really well with the manipulatives as far as what's happening. Students are getting some chance to actually do the regrouping, and they can start at either point. I don't have to start with the ones, I don't have to start with the tens in order to work through this problem. Okay? So the other strategy that we can use to do subtraction is do the standard algorithm. So the standard algorithm is what most of us learned when we were in school, and we're going to use the base 10 blocks to model that. We're going to stick with the same problem, 52 minus 19, and we're going to represent our 52. And we're always going to have a big stash of ones left over for the students so they can do regrouping if it occurs. We're going to take our problem and we're going to write it vertically. And we're leaving ourselves some space to also show this pictorially. So I'm going to use my base 10 blocks. I'm going to draw a picture and I'm going to do it abstractly. So we have our concrete, pictorial, abstract happening all at the same time, so the students are making that connection. With the standard algorithm, we start in the ones place. So we're going to ask the students, can we take away 9 from the 2? And hopefully they tell us no, and we say that's good. Now we're going to regroup. So we're going to take 110 away. We need to put our pictorial model up here. We're going to take 110 away. I'm going to model that on the picture. I'm going to model that abstractly. I had 5, now I have 4 left. And this is where I have to make the trade of 10. I'm going to take this 110 that I took away and I'm going to put it in my ones. So now I have 10 added here. And 2 plus 10 is 12. Now I can actually go through this subtraction from my ones place, and I can say 12 take away 9. And I can take away 9 here. And I have, to make sure that I mark the 10 that I took away over here, I have 3 ones left, and now I have this 10 that I'm taking away, and I have this left here. So here's my 3 10s, here's my 3 10s, and here's my 3 10s. Here's my 3 ones that I have in my concrete, pictorial, and abstract subtraction through standard algorithm. Remember that students do not have to have standard algorithm mastered until 4th grade. As we're working through these, we also have the strategy of using a number line. We're going to keep our same problem, 52 minus 19, and we're going to do a number line. There's 2 different methods for subtracting on the number line. We want to make sure that we expose the students to them and allow them to make that choice of what they want to do. We can count back, or we can count on. When we start with the count back method, we're going to start with the larger number, and we're going backwards on our number line. So we want to start at our larger, and we want to take away 19. Again, with number lines, we want to make sure that we're allowing the students to be flexible in the choices that they make in doing their jumping backwards. So they could jump by 10s and 1s, which is going to make it very simple. We can just use our 10s and 1s. Or they can get more creative, they can see numbers a little bit differently, and maybe they make one big jump of 20 and then they jump back more. So that there's lots of different strategies and different thinkings that the students can do. We're just going to break this one apart into 10s and 1s. So we're going to make one large jump of 10 backwards. So this is minus 10, and this is going to be 42. And then I'm going to make 9 jumps of 1 backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is all jumps of 1. And then I'm just going to count backwards. 42, 41, 40, 39, 38, 37, 36, 35, 34, 33. And so I can get to 33. I know that I started with 52, I took away 19, and I ended up with 53. We can also do the counting on strategy, and that means I want to do my counting all the way from 19, and I want to jump all the way to 52. And I'm going to use the information that appears up here at the top is the difference between 19 and 52. and this is what I'm going to put together to come up with my difference between the two numbers. I'm going to model how the students can be flexible with their using their jumps on their number line, and I'm going to start out by jumping by 1, because to me it's much easier to jump in groups of 10, counting by 10, 20, 30 than counting 21, 31, 41 for the students. So now I'm going to jump another 10. This is getting me to 30. I have to get all the way to 52, so I need to keep going. This is another 10. I'm at 40. This is another 10. I'm at 50. If I make another 10, I'm going to jump too far. So I either want to back down to 5s, back down to 2, or back down to 1s. I'm trying to get to 52, so I'm just going to make 2 jumps. 51, 52. Now I need to just count the stuff up at the top of my jumps, and that's going to be my difference between 52 and 19. 10, 20, 30, 31, 32, 33. So I know that my answer is 33. Either method is using a number line, whether the students use counting up or counting backwards. Okay. From there, we're going to allow the students a lot of time to practice. We want to make sure that when we're doing these practice situations, we're talking in scenarios as the teacher. We're not necessarily giving them word problems the students are individually solving, but we're talking about scenarios where they start to make a connection to the action that's happening in the scenario. Something's been given away, something's been lost, or we're comparing something from that. But from here, where students are going to move into word problems, we're going to allow the students to be flexible in their strategies of solving. They do not have to solve in any particular way. The good thing is that we're going to have the students use QTPAC to solve. There's the checking portion, and that will allow us to have them solve in 2 different methods. And so they're getting lots of practice in that. So when we think about the types of story problems we're giving students, we always want to go back to the different types of story problems that are out there. We're going to be giving students joining problems for adding, separating problems for subtracting, part whole models, and then our comparing word problems for subtracting as well. So we want to make sure that, especially for subtraction, we're focusing on these parts right here. If students use these joining number sentences, but they use subtraction to solve, that's okay too. But we're going to be focusing on here with our 2-digit and our 3-digit subtraction in 2nd grade. So we want to make sure that as we're solving word problems, students are using QTPAC, that they're solving 1-step and 2-step problems, and they're completing the graphic organizer. So we're going to look at 2 examples, and we're going to add in the teak of representing as well when we start to solve with QTPAC. So I'm going to slide this here. And we have our story problem. This story problem says Mark scored 26 points in a basketball game. Andy scored 39 points in the basketball game. How many more points did Andy score than Mark? So we're going to have the students work through QTPAC. How many more points? So our Q is we are looking at the points. In my data, I know that here it tells me that Mark scored 26 points. So I might write an M for Mark, 26 points. And then Andy scored 39 points. And I want to know how many more. So when I get to this plan, I need for the students to be able to identify the type of problem that we're looking at here. So it's going back. Were we joining? Were they separating? Is it a part whole? Or are we comparing? And hopefully in this problem, the students see that this is a comparing type problem and I need to subtract. So in my plan, the students are going to tell us what operation we're going to solve. They can write a subtraction sentence in order to represent, and they can also draw a picture, use a picture model. And a picture model we mean by looking at more of a bar diagram type model. So whenever we're comparing, so I'm just going to show this specifically, that this bar model for comparing, I have the one bar that's going to represent Mark, and Mark had 26 points. Andy is going to be my other bar, and I'm comparing the two. Is Andy's amount more than Mark? The answer is yes. So Andy's bar should be longer than Mark's bar. And I put in that Andy had 39 points. And what I'm trying to figure out is this amount right here. What is this difference? What is the space? In order to make Mark be the same as Andy, how many more points do they need to have? So I can represent this problem in a number sentence. I can represent this problem using a bar model, and this is what that bar model would look like. And then the students will go ahead and answer, and they can answer using their number line, they can answer using pictures, they can answer using a standard algorithm, they can answer using partial differences as well. And then they would want to check in another method. And even if they start to learn and understand that I can check by adding, that's okay too. But we want to make sure that they're also focusing on different ways to do their subtraction. So they would continue on working that way, but a comparing model, bar model, would look this way. Okay. Our second word problem that we have is Kelly made 72 bracelets to sell at the fair. She sold 65 of the bracelets. How many bracelets were left? So when we're working through Cutie Pack, we ask the students, what are we trying to find out? We want to know about the bracelets that were left. And it's okay to add a little bit more information as long as we don't write the whole sentence. Well, what information do we know about the bracelets? Kelly made 72 bracelets, and she sold 65 bracelets. So my plan, if I had some, I got rid of some, and I'm trying to figure out what's left, hopefully the students will say, well, that's either a missing part, or it's a part whole, or it's a takeaway, that's what I'm looking for, is that subtraction part. So my plan is to subtract. The students can represent by writing a number sentence. They can also represent using the bar model. So if I go back to thinking part whole, I can represent that she made a total of 72. She sold some of them, 65, and I'm trying to figure out what's left. And so if they start seeing that bar model, same thing that they used in other places to represent with addition, they'll start making that connection. Our bar model can also be written with the total on the bottom and the parts on the top. We can also model in more of a number bond type part whole model. This is our total. We know this part, and we're looking for this part. From this point forward, the students would subtract in their method. They would check in another method to come up with their answer for these word problems. Make sure that when students are working with the word problems that we're not using keywords, that we're using the action posters that we have. So it would be time for us to go ahead and introduce, if we haven't already, the compare and takeaway or action posters for the students to use to help in their solving. The final part of the set of TEKS for subtraction with the word problems is for the students to generate and solve problem-solving situations when there's a given number sentence. So we're not just going to have the kids randomly just create your own story problem, but we want to give them a number sentence like this, something minus 14 equals 50. We want to give them this, and they have to then generate that problem. Their problem should contextually match the number sentence that's given. So we would have, John had some pieces of candy, he ate 14 pieces of candy, and now he has 50 pieces left. How many did he start with? That scenario or that problem has to match this context in this number sentence. So our biggest pieces are being flexible with the strategies that the students are using for subtraction. When they get to word problems, making sure that they're using their Cutie Pack strategies to think through the problem, focusing on the actions and not the keywords, and making sure that they're generating problems that match the number sentence given. If you have any questions on subtraction, let us know.